Hey dudes, sorry I can't be here with you today. My daughter's sick, and so I'm hanging out with her and cleaning up barf, which is very exciting. We're checking out scientific notation. Last time I was with you, we worked on a little bit of a investigation, and we're gonna kind of move ahead with that. So I think scientific notation works really well if you understand how to just say these together. This is 2, and this is 2/10ths, and this is 2/10ths, hundredths, thousandths, and this is 2/10ths, hundredths, thousandths, 10,000ths, and this is philanthropist. It has nothing to do, but it's just a fun word to say. So this looks like this: 2/10ths, right? Because this is the number 2, and it's in the tenths place. This is 2, the number 2, but it's in the hundredths place. This is the tenths place. Sorry, this is Hey dudes, sorry I couldn't be here with you today. My daughter's sick, and so I'm staying home with her and cleaning up barf. We're looking at scientific notation, and so um, if you can say these pieces, then I think that'll help you with scientific notation. So this is the number 2, and you say 2, right? This is the number 2, and it's in the tenths spots. You say 2/10ths, right? 2/10ths. This is the tenths, this is the hundredths, and this is the thousandths spot. So this is 2,000ths, and this is tenths, hundredths, thousandths, 10,000ths. So this is 200,000ths, and this is the word philanthropist because there's a lot of spitting involved in all of these. All right, so if you can see the place value, it makes this easier. So let's check that out. Scientific notation is just a short way to write really big or really small numbers. It's when we don't really want to write all these ridiculous zeros. We write it in a shorter notation. Or all of these zeros, we write it in a shorter notation. And sometimes it's not shorter, but it's often easier to use, and we'll see why. But you noticed yesterday that it's a single digit followed by times 10 to the and to a certain power. This is called scientific notation. The British call it standard notation. And when it's just a regular number written out, even if it's really big, it's called decimal notation. That got a little fuzzy, but that's okay. But this and this are the same thing. If you punch them into your calculator, you get 1,300 for both of them. But this one's not scientific notation because it doesn't have a single digit with the decimal. It has a double digit, so it's really close, but it's not quite the same. So we want single digit with some decimal, and then times 10 to the. Cool? So let's, if it was a little fuzzy yesterday, let's try this. Here's 1, right, sort of in the middle. If you move this way, maybe you could think about this as 10, 100, 1,000, 10,000. You're sort of multiplying by 10 each time. This, if you divide by 10, you get a tenth. If you divide again by 10, you get a hundredth. And if you divide by 10, you get a thousandth. This is the decimal form, but you could also think about it as a fraction form. 1/10, these are equivalent, right? 1/100th looks like that. 1,000th looks like that. You could also think about it like this. On this side, we got the regular numbers, right? 10, 100,000, 10,000. But 1/10, you could think about 1 over 10 to the first power, maybe. And 100, you could think about as 1 over 100 squared, right? So this one is really like 1 over this one. And this one is really like 1 over that one, etc., etc. You could even go so far as to say this. this is 10 to the fourth. This is 10 cubed, 10 squared, 10 to the first, 10 to the 0, 10 to the negative 1, right? It's in the denominator. The 10's in the denominator. So we could move it up to the numerator by changing the sign on the exponent. Same thing like this, 10 to the negative 2. We could get rid of this fraction by turning this exponent into a positive and pulling it up out of the fraction's denominator. Same thing here. So for big numbers, say 3,000, you could call it 3 times 1,000, and then you could call 1,000's nickname. You could call it 10 to the third. So that's where 3 times 10 to the third comes from. It's 3,000 is 3 times 1,000, and 1,000 really is 10 to the third, 10, 10, 10, 10, 10. Same thing here. Oh, where'd my little blank go? Here, I hide it so you can't see it. This is tenths, hundredths, thousandths. This is 4 thousandths, which means 4 times 0.001 or 4 times 1 1,000th, right? And 1 1,000th really is 10 to the negative 3, and that's where that idea comes from. Cool. So you found some shortcuts yesterday, and the shortcut was this, right? Well, I hate everything. I hope you don't hate scientific notation. I forgot that was there. Some of you found this this switch where you could say, all right, well, this is, instead of writing this out and saying 5 times a million, right? You said this is 5 times 10 to the 6, and a faster way to do that was to take this decimal. We want to make this 5.0, and you moved it 1, 2, 3, 4, 5, 6, and you moved it 6 places, and you were making 5 a big number, so it's 10 to the 6. It's a positive number, so you get a bigger number here. You can do that same thing here. You can call this 3 times 1 1,000,000th, and you're just moving the decimal point the other way. Here the decimal's right behind the 3, so if you were going to move this behind the 3, you'd say 1, 2, 3, 4, 5, 6, but you're moving it in the opposite direction. You're making a small number, so you should have a negative exponent. Cool. Take a second, pause me, and try to turn this into scientific notation. Turn this into scientific notation. Take this and turn it back into, this should be decimal notation, and this should be decimal notation. Try that, and I'll go from there after that. All right, so this should be 1.496 times 10 to the 8th because you moved 8 decimal places to the left. This was the distance from Earth to the Sun in kilometers. This, if you move the other way, it should look like 7.8 times 10 to the negative 6. It's the diameter of a human hair. If you wrote this in decimal notation, you'd move the decimal to the left, right, to make it a small number. That's what the negative implies. And it would look like that. It's the diameter of a bacteria, common bacteria. And this, the same sort of thing. This is the speed of light in meters per second. Cool. In a vacuum. All right. Pass on that one. You also figured out some techniques to use were combining with multiplication or division. And this is really one of the places that scientific notation shines, more than just writing numbers in smaller format. So if you had 2,000 and 4,000, or sorry, 40,000, and you multiplied them, yeah, you'd say 2 and 4 gives you the 8. And then you got all these zeros, and you got to figure out how many zeros. If they're in scientific notation, this is 2 times 10 to the third, this is 2 times 10 to the fourth. You guys figured out that you could easily take the 2 and the 4, you'd multiply, and then you'd take the 10 to the third and 10 to the fourth and multiply. And this is because you can take numbers like 2 times 3 times 4, and if you multiply them together, you get, what, 24. Sorry, I'm writing with my finger. If you switch the order, 3 times 4 times 2, and you multiply them, you still get 24. It's called the commutative property of multiplication, and we can use that to our advantage here, and we could write this out as 2 times a bunch of 10s. Here, let me try to do it in a text format instead. You could say 2 times 10 times 10 times 10 times that 4 times the 10 times another 10 times another 10. Oh, I'm running out of space. Times another 10. Right? So instead of multiplying them out like this, you just move the 4 over, switch their order, multiply the 2 and the 4, that's where you get the 8, and then multiply the 3 2s and the 10, sorry, the 3 10s and the 4 10s, and that's where you get the 7 10s. So you can do the same thing here. This is 1.5 times 10 to the 4th, this is 2 times 10 to the 3rd, and you can multiply them together and get 1.5 times 2 is 3, and 10 to the 4th, and 10 cubed is the 7. Neat. Dividing is the same sort of thing, right? If you change this is 4 times 10 to the 4th and 2 times 10 to the 3rd. You divide the coefficients, you get the 4. Oh, that's even too much work. And then combine the 10 and the 3, you subtract those exponents. So you get 2 times 10 to the 1st. Try it with this one. So this is 3 divided by 2 gives you 1.5. And the 5 divided by the 3 gives you the gives you the 2 there. Cool. Here's the one hiccup. If you if you do this same thing, this is 6 times 10 to the 1, 2, 3, 4. And if you multiply that by 2 times 10 to the 1, 2, 3, when you multiply the 6 and the 2, you get 12, right? And then you get times 10 to the 7. The only problem is that's not in scientific notation because this isn't between 1 and 9. So we're going to take this, the 1.2, and turn it into 1. This is 12 is really 1.2 times 10 to the 1st power. And then also we have this stuck on the back, times 10 to the 7th. So now we can combine the 10s, and that's why you get the 1.2. And times 10 to the 8th. Times 10 to the 8th. Now that's in scientific notation. Sweet. Not sure if I have hiccups or just having some sort of fit. So here's some rules if you'd like to copy them down. If you're comfortable with them, keep going. In your packet, you can either look at this piece, which is the scientific notation practice, going back and forth between scientific notation and decimal. It's in your packet. Don't worry about this piece. The answers are on the back. We're working on that as your homework, and also this operations with scientific notation. If you're done with that, there is a video about how to do all of these problems. We had problems that look like this that were big and ugly. I did a video for each and every one of them. So you were only supposed to do 6, so pick whichever 6 out of the 12 that you like and fast forward me if you get done. So you're kind of going back and finishing any of those if you get done with these. Cool? Again, sorry I couldn't be there, but I hope that this makes sense, and I'll see you later. Bye.